Hi, algebra students, it's Mrs. Clear. You are seeing the start of a video I want to show you. This is actually something that Mrs. Goslin suggested. It might mean that you have to hear me sing a little bit later. I'm doing it at the beginning because I think I'll mess it up if I have to try to insert this somewhere in the middle of this recording. So this is a commercial back when I was a kid about Oscar Mayer bologna. And this little boy's super cute, so hopefully you can appreciate it.
My bologna has a first name, it's O-S-C-A-R. My bologna has a second name, it's M-A-Y-E-R. Oh, I love to eat it every day. And if you ask me what I'll say, 'cause Oscar Mayer has a way with B-O-L-O-G-N-A.
Okay, you'll see why we did that in a little bit. Now, here's going to be the trick for me. I have to try to switch cameras, so I'm going to pause this recording. Okay, eighth graders, thanks for being patient with me. This lesson is going to start our chapter 3, and you should have completed this activity called Define Me, where you're using examples and counterexamples to try to come up with a definition. And this is something you will do a lot in geometry when you get there, okay? So if you don't have the pink paper, Define Me Polynomials, in front of you, you should grab that. Now, you're either going to be doing this potentially on October 8th if you're Group A, or Monday the 19th if you're Group B. Keep in mind, you can do it any day, just so long as it is done before your next in-class session, okay? Okay, so this is going to be a lot of writing. Hopefully you have something to write with as well. Probably going to have you pause at some point so we can copy something down on the back of this, all right? You might want to add that although this is in chapter 7 of your Big Ideas textbook, we refer to it as chapter 3 at Eagle Crest and here at Thunder Ridge, okay? All right, so again, a lot of these you've hopefully come up with. We're just going to put a more formal definition to it. So for a polynomial, it's really 3 things. It's a term, or a sum or difference of terms. Now, sometimes it's best to describe something by what it isn't. So we are going to include some things that cannot be considered polynomials. So for it to be a polynomial, you can have no, we're going to do 3 things that we can't have. We can't have a variable in the denominator. No variable in denominator, and I'm going to have to abbreviate that because I ran out of room. We also can't have negative exponents. And if you think about that for a minute, when we have a negative exponent, to simplify it, we move it to the denominator, right? And we also can't have a rational exponent. Now, we haven't done this yet, but rational exponents are fractions, okay, in our exponents. So these are things that would disqualify something from being a polynomial. Otherwise, it's a term or sum or difference of terms. Okay. Well, the opposite of that would be where all the terms were multiplied by -1. And you've done a lot of that probably in solving our systems. We were trying to create opposites for things to eliminate when we were solving the systems. So how do you do that? If you're going to combine, well, you multiply by -1 and you create those opposites, right? I guess we should talk then about, well, what is this term that we keep referring back to? So term is a number, or it could be a variable, or it could be a product. And that's kind of almost a combination of those two. So, you know, if we're talking about, well, a number, you know, like 7, okay, or a variable like x. If it's a product, it would be more like 2x cubed, where all those are multiplied together. 2 is a term if it were on its own, x is a term if it was on our own, but if we have x times x times x, now we have a product. But all these are considered terms. Now, we get more specific when we're naming terms by saying, well, how many are there? If it's a monomial, then that is a one-term polynomial. Now, poly means many. Okay, nomial means like many. So mono, 1, bi, 2. I'm just going to do ditto marks, meaning the same as above, and tri, 3. And then once we get past that, if we get to 4, 5, 6, we just start saying a 4-term polynomial, 5-term polynomial. But we specifically use monomial, binomial, trinomial when we are naming or classifying. So this is a classification. Polynomials, to be more specific about what type of a polynomial we have, okay? Okay, well, what about the degree of a term or a polynomial? Well, the degree is the same as the exponent on a variable. So we're gonna, sometimes in notes it's a little caveman-like, right? But that's okay. If it's not there, if you don't see an exponent on a variable, then it's just an invisible one, right? It's actually there, why are we writing that? So it could be that there's this invisible one, if it's not there. I'll just write not there with a question mark, okay? Now, we could have no variable. So, or, if it's just a constant, if just a constant, and a constant being that number, if it's a constant, then that degree is 0. Now, that does not mean that that constant number has an exponent of 0. Anything with an exponent of 0 is 1, right? Its degree is 0 if it's just a number. Degree is the exponent if it's a variable, okay? Okay, what about the degree of a polynomial then, where we have maybe a sum or a difference of many terms? How do we choose what the degree is? It has to do with the degree of a term being, the exponent on the variable. Well, what if there's more than one? If that's the case, the degree is the highest. So the highest degree of the terms in a polynomial. So we look at all the terms and say, well, which one has this highest degree or exponent on the variable? Okay. Okay, coefficient. We kind of know this already. It's that numeric factor of a variable. So numeric factor, factor being numbers we multiply together, numeric factor of a variable. Okay. Leading coefficient. Well, that's going to be the coefficient of the term with the highest degree. Okay. So the coefficient, I'm going to abbreviate, of the term with the highest degree. And that really leads well into this last one, which is standard form. If we have a polynomial that's in standard form, the leading coefficient is going to be in front because it is going to go in descending order by degree. So standard is in descending order. By degree. Okay. So an example of that, we might have 3x cubed plus x squared minus 4. Okay. Well, it's in standard form because the highest degree is 3, and then the next highest degree is 2, and then the next degree is 0. The leading coefficient here would be 3 then. And this has 3 terms, and so we would call it a trinomial. Now, the other way we classify polynomials is not just by how many terms there are, but it is also by their degree. and we need to know those names. They're special as well. So if you can turn your paper over, I'm going to give you a minute to copy down this chart, and then you'll kind of get a feel for why we listened to that song. So I'm going to pause the video for you and for me. All right, algebra student, here's where you have to endure a little bit of singing. All right, so we're going to go back to that song about baloney, but now it's going to be about your polynomials. So my polynomial has a first name. It's based on its degree. My polynomial has a second name. It tells how many terms. But that's all you have to endure. Think of that. Maybe that'll help you remember. We have to name it with 2 names. All right. By the way, you have to tell Miss Gosselin I actually did that because she didn't. All right. All right. So if we name a polynomial by its term, and it just has 1 term, we're going to call it a monomial. And hopefully you remember the rest of these. If it's got 2 terms, then it's going to be a binomial. If it has 3, a trinomial. And 4, we just say it's a 4-term polynomial, 5-term polynomial, 6-term. We stop naming after that, but we do say how many terms it has. If we want to use these words, these specific words for 1, 2, and 3 though. Well, what about degree? If we had a 0-degree polynomial, hopefully you remember, that means there's just a constant number. If that's the highest degree there is in a polynomial, it's because it's just a number. So it has a degree of 0. So for example, 6. Okay. If it has a degree of 1, where the highest exponent on the variable is 1, if you remember, that is a linear function. And so in this case, it would be a linear polynomial. So, something like 5x plus 9. The invisible 1 is our exponent. If we have a 2nd degree polynomial, we will name it specifically where it has an x squared, like 4x squared. Remember from our anchor problems, that is quadratic. So 2nd degree, highest exponent is 2 on the variable. And then if we have a 3rd degree exponent of 3, we talked about this a lot, but that is cubic, and hopefully you remember that from some of your geometry. Now, yes, technically we could go to 4 and call it quartic, and we can even go higher than that. But after this, we probably just start saying, just like the other one, a 4th degree polynomial or something like that. Okay. Now, I started these as examples of how it is named for degree, but let's give an example that is this is a binomial that's linear. This is a trinomial that's quadratic. So I would need 2 more terms here, like minus 7x plus 3. And right here, 4-term polynomial that is cubic. Well, I got the cubic part. Let's just come up with 3 more terms to balance this out. Quartic again, anything to the x to the 4th power. Now I'm not putting any coefficients on here, but they certainly can have it, right? Notice that these are also in standard form. They're descending, right? Okay, so you're going to have some practice on this in classifying polynomials. And we again classify it by 2 names, okay? Oscar, Meyer, and term and degree. You need to use these words, monomial, binomial, trinomial, or start with 4-term, 5-term, 6-term. And then for degree, we need to use these, constant, linear, quadratic, cubic. And after that, you don't have to remember quartic, but 4th degree, 5th degree, 6th degree, okay? Okay, if you have any questions, you could probably be Googling just polynomial classification or emailing your teacher. Hopefully you do well though with your practice. If you need anything, just go ahead and email your teacher, okay? Good luck.